Hello children. In this video, we are going to discuss some important terms related with excitation and de-excitation of electrons from its orbits. Let's discuss each term one by one. So the first term we are going to discuss here is the excitation energy. Excitation, excitation energy. Now we all know that hydrogen atom usually in their lowest energy state will be n is equal to 1 state. So hydrogen atom usually in their lowest energy state when n is equal to 1. And we call this state as ground state. Right? This is called as ground state. So if I'm observing the energy level diagram, n is equal to 1 state, which is marked here, is my ground state. Or otherwise I can call it as the unexcited state. Now if you are going to bombard this hydrogen atom or any other atom with particles like electron or proton, what happens is these atoms get excited. Or due to the collision, this atom gains some energy, or there is an exchange of energy between the bombarding particles like electron and proton. With the atom, there is an exchange of energy. As a result, electron jumps from its ground state to excited state. Now we have explained n is equal to 2 represents the first excited state, n is equal to 3 represents the second excited state, n is equal to 4 represents the third excited state, and it will go on like that. Now, whatever minimum energy you are supposed to provide to the atom in the ground state to make it move to one of the higher stationary state is called as excitation energy. So if I am going to explain it using this diagram, if you want to make an electron from n is equal to 1 state to jump to n is equal to 2 state, whatever energy you are supposed to provide is called as excitation energy. Or you can make the electron jump from ground state to the second excited state. For this also you have to provide some energy. So whatever energy you are going to provide here is called as excitation energy. So excitation energy is the minimum energy required to excite an atom in the ground state to one of the higher energy states or higher stationary states. Now let me explain this with the help of one example. Now we know that the ground state energy E1 for hydrogen atom is minus 13.6 electron volt. Right? And for the first excited state, the energy value is minus 3.4 electron volt. It's shown here in the energy level diagram. And for the second excited state, E3 will be equal to minus 1.51 electron volt. And if you are considering an electron which is at infinity, the energy will be equal to 0 electron volt. Now, if you want to take or if you want to lift the electron from ground state to first excited state, ground state to first excited state means here you have to take the electron from n is equal to 1 level to n is equal to 2 level. How much energy you have to provide? So E will be equal to E2 minus E1. That will be equal to minus 3.4 minus 13.6. This will be equal to 10.2 electron volt. So whatever bombarding particle you are going to use here, that bombarding particle should have an extra energy of 10.2 electron volt if you want to excite the atom from n is equal to 1 state to n is equal to 2 state. Now let's say I want to excite the atom from n is equal to 1 state to n is equal to 3 state in the case of hydrogen atom. So what will be the energy value of the bombarding particles? The energy of the electron in the third level minus energy of the electron in the ground level. Or I can say energy of the electron in the second excited state minus energy of the electron in the ground level. So this will be equal to minus 1.51 minus 13.6. This will be equal to 12.1 electron volt. So if you want to excite the electron from ground state to second excited state, the energy that you have to provide for this atom will be 12.1 electron volt. Or the bombarding particle, whatever particle is going to come and hit the atom, in order to excite it to the second energy level, it has to provide an energy of 12.1 electron volt. This energy that you are providing is called as excitation energy. Now we have to talk about excitation potential. If you have understood excitation energy, understanding excitation potential is very easy. Excitation potential. Now excitation potential simply means it's the minimum accelerating potential you are going to provide. Previously it was the minimum energy you are providing. Here you are providing minimum accelerating potential that you are going to provide to an electron to jump from the ground state to one of the outer orbits, okay, or one of the higher stationary states. That potential you are going to provide is called as excitation potential. Calculating excitation potential is very easy. Now if you want to make an electron jump from n is equal to 1 state to n is equal to 1 state to 2 state, what energy you have to provide? We have calculated it. It is 10.2 electron volt in the case of hydrogen atom, right? If you want to calculate excitation potential, the excitation potential I will write as EP. That will be equal to whatever energy you have calculated in electron volt, or the energy difference you have calculated in electron volt, that has to be divided by the charge of electron. So that will be equal to 10.2 electron volt divided by. So this will be equal to 10.2 volt. So you have to provide a potential of 10.2 volt if you want to excite an electron from ground state to the first excited state, or you can say excite the hydrogen atom from its ground state to first excited state. So you have to provide a potential of 10.2 volt. Now if you want to excite an electron from n is equal to 1 level to n is equal to 3 level, the energy difference between the two levels we have calculated previously, and it was observed to be 12.1 electron volt. So if you want to calculate the excitation potential associated with this transition, then it will be delta E divided by E. That will be 12.1 electron volt divided by E. So that will be 12.1 volt. Okay. So you have to note that the value of the excitation potential depends on the state to which the atom is excited from the ground state. From ground state to which higher level you are going to excite the electron. Depending on that, the value of excitation energy as well as the excitation potential is going to change. Okay. I hope you understood what do you mean by excitation energy and excitation potential. Remaining things we'll discuss in the next video. Okay. Thank you.